Next up on this specific video, we are looking at reflecting of a graph about the y-axis. So to explain this concept, we'll look at this figure. Let's say if we had an old graph named f of x, and we are required to reflect this about the y-axis. Remember I said reflection means a mirror image. So they are asking us to transform this, or rather make a mirror image of it about the y-axis. So on the x-axis we had to mirror it about the x-axis, but on the y-axis we need to mirror it about the y-axis. So now we'll do as we did on the reflection about the x-axis analysis. We'll first look at the effect on the x coordinate, and then we'll look at the effect on the y coordinate. So we'll define this newly reflected about the about the y-axis graph as g of x. So now if for instance we had y values of 1, 2, 3 and 4, notice that on the old graph we have a value of 1, but on the new one again we have a value of 1. Here we have a value of 2 on the old one, and then on the new one we have a value of 2. And then if you do this again on all the values, you'd learn that when you reflect a graph about the y-axis, the y values do not change. They do not change. However, now let's look at the effect of reflecting a graph about the y-axis, and now we're looking at the effect on that on the x values. Let's say if we had a value of -3 here, reflected about the x, about the y-axis, then we would have a value of 3. If we have a value of 2 here, and then we reflect that about the y-axis, we would have a value of -2. So then this means that to write this in summary, when doing a reflection, y-axis reflection on the old graph and on the new graph. So we would transform this from a value of x to a value of -x, because we've seen that the y value, the x values, they change signs. They change signs. And however, the y values here, we've seen that they remain the same. So from a graph of f of x required to be transformed, or rather reflected about the y-axis, every x value becomes a negative and every y value remains the same. So to write this in summary, or rather when given an f of x graph and you are required to transform it about about the y-axis, then we would define a new graph named g of x, right? And would let it be equal to the old graph. However, every x value needs to be negative. So now let's look at this specific example to sort of explain this concept. Here on this example, they say determine the new equation g of x of x squared minus 4x plus 4 reflected about the y-axis. You need to ask yourself each and every time when they ask you to reflect about the y-axis, what does it mean to reflect about the y-axis? You need to then be able to remember these properties that we've defined above, that when reflecting about the y-axis, we see that the y values remain the same, but the x values, they change signs from a negative to a positive, or from a positive to a negative, right? So the first thing that we do is we need to use that definition. Then we say g of x equals to that old graph, but however, every x value then changes sign, so that's why we add a negative. So you notice that initially we had on the old graph x squared minus 4x plus 4. So now we add a negative on each of these x's because it's reflected about the what? About the y-axis. And when reflecting about the y-axis, x changes. So we add a negative x squared minus 4. So instead of an x, we add a minus x. So do you notice every x is replaced by minus x and then plus 4. So if you simplify this, then this will remain the same, and that will be a plus, and we have that. So now this is the new graph of g of x that we have. So if we try to draw this is the f of x graph. This is the f of x graph. and then it was reflected about the y-axis. So this is the new graph now, newly reflected. So if you try to draw it, you'd see that it would look like this, the newly reflected graph, this one. It will look like this. So again, I want to draw your attention to the fact that the y values remained the same. Notice that the old graph cuts the y-axis on 4, and the new graph also cuts the y-axis on 4. And however, if you look at this graph, the old graph, it cuts the x-axis at 2. The new graph cuts the x-axis at -2. So do you notice again, this uses the same analysis that we had before, that when reflecting a graph about the y-axis, y remains the same, but the x changes the sign to a negative.